What is the Big Bang theory of the universe? The Big Bang theory is the idea that around 13.8 billion years ago, the universe started from a singular point of extremely high temperature and density. It explains that the universe expanded from this point, causing it to stretch out and grow. The rate of this expansion began at incredible speeds, beyond the speed of light, but later began to slow to a more measurable rate. During reheating, a flood of matter and radiation began populating our universe, atoms and particles, which comes together to form everything. Why did many astronomers not support the Big Bang theory when it was first proposed? Many astronomers did not support this idea when it was first proposed in the late 1920s due to it being a very religious time. This idea went against the belief that God made everything, instead giving it a scientific origin. Another key reason people had their doubts was due to the Big Bang violating the first law of thermodynamics. The fact that all of the universe's energy and matter came from practically nothing in the eyes of many drove support away. The fact that the Big Bang wasn't the only theory on the universe's creation also played a factor, being cast aside in favor of already prevalent concepts. Finally, the law of entropy suggests that systems will eventually become less organized over time. Our universe has appeared to do the opposite, being more organized now compared to how it was shown in the beginning. Why was the discovery of the cosmic microwave background so important? The discovery of the cosmic microwave background was crucial evidence towards the Big Bang theory. It was first believed in 1948 that if the universe had in fact started from an explosion that some kind of evidence would be left behind. The high temperature released during the creation of the universe would result in a thermal radiation field, which would be distributed in a way that would be very distinguishable from everything else. As the universe grew older, this thermal energy would have decreased. The light released from this explosion would have redshifted thanks to the expansion of the universe. The CMB showed scientists that some kind of explosion occurred that greatly resembled the idea of the Big Bang in our universe. What evidence is there for the Big Bang? The redshifting of galaxies occurs due to the fact that the light we see coming from galaxies is stretched by time, moving further towards the red of the light spectrum and being redder the further out the galaxy is. This supports the Big Bang as it shows us that different galaxies end up moving at different speeds. It also allows us to determine the direction that galaxies are expanding in, which allows us to find out the center point of our universe, where the Big Bang would have happened, showing that everything would have expanded out from it. Why do astronomers think that the expansion of the universe is accelerating, and what evidence do they have? Scientists have believed that the universe's expansion has been accelerating since 1998. This conclusion was reached when determining the expansion of the universe when viewing the redshift and luminosity of supernovae. By determining the light given by this redshift, scientists have the ability to determine the distance of the supernovae from Earth, with ones closer being far more luminous. When comparing this data to pre-existing models of the universe, scientists can determine where everything should be, and when this doesn't match the maths, instead being further away, we can tell that it is accelerating in its expansion. The supernovae that were further away moved faster compared to ones that were closer to us. Describe what would have been the effect on the expansion of the universe if its density had been greater than a particular value. The universe's density is crucial, as any more than a critical size would result in its collapse. This would occur due to gravity being able to overwhelm the universe, causing it to fall in on itself, often referred to the Big Crunch. The expansion therefore of the universe would eventually stop due to the universe having sufficient mass. If the mass of the universe was too low, then expansion would happen indefinitely thanks to gravity being unable to stop it. What is going to happen to the universe in the future? The exact future of the universe is unknown to us thanks to the current limits of our knowledge. However, this does not mean we are completely clueless as to what might happen, with us having four main ideas. These ideas are all based on the actual density of the universe. The Big Crunch is the idea that the universe shall eventually collapse into itself due to gravity finally winning. This will occur if the density of the universe is greater than the critical density. The second main idea is that the Big Freeze will occur. In this case, the universe's expansion will grow so large that there will not be enough hydrogen gas for stars to form. This results in no new stars, and in time the existing ones will finally burn out, resulting in only black holes left behind. As everything begins to die out, our universe will grow colder, leaving nothing behind. The Big Bounce tells us that the universe never truly ends. It believes that the universe will eventually stop expanding, similar to how the Big Crunch portrays it. However, in this case the collapse would cause another Big Bang, which would create an endless cycle of universes. Finally, the heat death of the universe believes that when all energy is equally distributed, no more work can be done. There will no longer be places of high energy and low energy, instead being the same everywhere. This essentially is the death of the universe.